We have, yeah, I'm gonna film nothing. It's the main body, it's the nucleus. It feeds the neuron. It allows the neuron to function. It provides protein for the neuron. And it does this, it sends the protein from the soma all the way down to the dendrites and the axon terminal through tubules. And it also uses microtubules. So it has all these tiny little tubes running through it, and that's how it feeds it. Now the reason that these microtubules are important and the microfilaments and the tubules are important is because sometimes when we are using a pharmaceutical, that pharmaceutical blocks these tubules or it slows it down. That's one of the ways that, that's one of the types of the beta blocker. That's how it functions. It blocks the microtubules. So it slows down the neuron and the neuron responds. Damn it. Why can't I get this thing to work? I could just keep punching buttons, that might work. Anyway. Glial cells are the construction cells. They're like the scaffolding that holds up the neurons. It keeps the neurons in the right place. Come on. It keeps the neurons in the right place. The glial cells, and there are different types of glial cells. It also forms a protection. It protects the neurons. So as humans, of course, we get blasted around all the time. We get knocked around all the time. And if we didn't have the glial cells, of course, the neurons would become damaged and they wouldn't function anymore. But that's not the way it works. Normally, you have something around the neuron that protects it, and this protective substance is known as the glial cells. There's an equal number of glial cells as neurons. So there's at least one glial cell for every neuron. There are 4 different types of glial cells, and the reason that they have these really funny names is because that has to do with the structure. The first ones are called astrocytes. They're star-shaped. Astro, get it? Astrocytes, okay. There's microglial cells, which are tiny little things. Oligodendrocyte means tiny little trees. And these are structures that surround the neuron and protect it. And the 4th type is known as a Schwann cell. It's not because they look like swans, it's because Schwann is the one that discovered them. So there's 4 different types of glial cells. The astrocytes are for protection because the star shape is very strong. The microglial cells, of course, are around neurons, protecting them. They are tiny little things, but you stack a bunch of them up and you've got a fairly strong structure. Oligodendrocytes, of course, do look like trees, and therefore they protect they actually make up myelin in the brain, the central nervous system, the oligodendrocytes. But as you can imagine, they are a large structure with lots of fingers that protect the neuron. The last type is a Schwann cell, and that's in the peripheral nervous system. That's your legs and your muscles, your muscle mass, and they provide protection for the. They provide protection for those neurons. Okay, let me see if I can get this damn thing to work. They probably touched something. Somebody was playing with it. Who knows about this stuff? Wait a minute. That's right. 1, 2, 3. Home network, Miracast, and HDM3. I think HDM3 is. Come on. And I just turned it on. Oh well. This is not turning out to be a good day. Oh, you know who was in here? It was Marius. Marius was he was in here yesterday.
Well, I
So-
go to the 6th floor and I saw him about, maybe like 10, some here. It was real fun for him.
Yeah, he's playing with that television, that's what he was doing. And that thing was working yesterday, so he must have screwed it up somehow. It's Marius's fault, that's good. Now I know who to blame. Astrocytes are star-shaped glial cells that protect neuronal bundles, especially in the brain. Astrocytes, because they're star-shaped and it's such a strong structure. The Dura Mater. Dura Mater means tough mother. I know that sounds like we're about to swear, but we're not. Dura means tough and mater means mater means mother, so it means tough mother. And durable. Dura is Latin for strong or tough. So the Dura Mater covers the brain. It's like a plastic covering over the brain. It's not plastic, of course. It's made out of astrocytes. And if you've ever, of course, neither of you have ever cut into a brain, but if you'd ever cut into a brain, you would see this whitish, grayish covering, and it looks like it's relatively thin. One of the things the first thing that you have to do if you're doing brain surgery is cut through this Dura Mater. Well, you have to crack the skull, of course. Once you make a hole in the skull, then you can get in there, and the first thing you have to do is cut this stuff. And it's really kind of interesting because no matter how sharp your scalpel is, you still have to push fairly hard in order to get through this Dura Mater. In order to get purchase on this Dura Mater, so you can slit it open. As curious as that is. Astrocytes contribute to the metabolism of the neuron and provide restorative protein. A lot of these, one of the interesting thing is this has to do with doing away with waste products, the glial cells. So the glial cells not only feed them, but it also takes away the waste product. The waste product becomes extremely important, especially if you're talking about Alzheimer's disease or dementia, because that's one of the reasons why you develop Alzheimer's disease, is the waste products build up in your brain and it destroys the neurons. Microglial cells are very small, and that's why they're called microglial cells. They're really kind of cool because they migrate to areas where there is injury, and they are the ones that clear out the debris. If somebody has TBI, if somebody has a brain injury, it takes a couple days for them to just even regain consciousness, and a lot of times that has to do with the fact that these microglial cells have to do their job. They have to get in there, they have to clean out all of the damaged material that's in there. And this is a relatively, it's not that slow a process, but it takes time. It does take time.
Where you're unconscious?
That's one of the reasons why you're unconscious. There's two reasons why you're unconscious. One of them has to do with this, and the other has to do with a buildup of fluid in your brain. Anytime your body is injured, that portion of your body will swell up. And the reason it swells up is because the body is trying to protect it from more damage. So it'll make it swell up. So if you sprain your ankle swells up. And of course, we can't do anything as medical people. We can't do anything until the ankle goes down. The swelling is an immediate reaction. So if we try to do something, what will happen is that the swelling will continue. Now we don't want the swelling can't continue. If that fluid buildup continues, then it will start breaking down tissue. So if there's too much edema and the edema stays in the area for too long a period of time, it will destroy the tissue in the area, because this is not functional. This is fluid. This is not something that helps. This is something that protects, and that fluid has to go down. Otherwise, the tissue will start breaking down, and that's what happens with people's knees. If somebody gets water on the knee, you've got to draw that water off, and you need to do it fairly quickly. If you don't, then the knee will start to not really decompose is the wrong word. It'll start breaking down. And it'll dissolve cartilage, and now we've got all kinds of problems. And we see this in football all the time. An individual will injure themselves, they won't say anything to their coach. Next thing you know, they'll hurt their knee. The next thing you know, and it swells up, of course, and they get water on the knee. The next thing you know, that they've got all kinds of knee problems. Their meniscus is breaking down. And this is one of the reasons why in the old days, the football players, after they stopped playing football, they were hardly functional at all. They were almost crippled. And it was mainly because of all the blows that they had. The same thing happens to your head. If we can't take some of the moisture out of your brain, then it's going to start breaking down your neurons. So what they will do is they will put you in a coma, and of course during the coma, that whole process is taking place. The process of clearing out all the debris, the process of the moisture being there, then the moisture dissipating. And that's one of the reasons why they put you in an induced coma.
So that's what was going on when I was at launch room?
Right. Oh, you're a launch stool?
Yeah, that's where I got medevac to.
Okay. I was a Ramstein, so right down the hill.
Yeah, really, they're falling on.
That's kind of I'm not going to say shitty on visit. That's not a very nice hospital. It's
Well, it freaked me out. I was out for like 2 days, and I woke up, I don't know what the heck was going on. I pulled the IVs out, I made it like 5 steps.
crashed.
Yep. And then I stayed another 3 days, and then I went back to my room.
Well, they knocked you off. They put you in an induced coma, I'm guessing, in order to make sure that your brain recovered properly.
Yeah, I had one of those tubes in my throat.
Sure.
I guess I couldn't breathe by myself.
They were trying to help you. Well, they were feeding you through the tube for one thing, but they were trying to make sure that you were taken care of, that you weren't going to starve to death, or that you weren't going to stop breathing or something. A launch stool, I always found a launch stool looks like old dormitory buildings or something stuck
It's like the
together.
Motel 6 of hospitals.
It's an ugly, ugly hospital. They were going to give it to the Air Force. They were going to trade hospitals, Wiesbaden for Landstuhl. And the Air Force was going to take over Landstuhl, and the Army was going to take over Wiesbaden. Instead, they closed Wiesbaden, and they left Landstuhl open for no reason whatsoever. Yes, I know why. It has to do with money. Somebody was making money. Yeah, sounds right. Myelin sheaths that surround and protect the neurons are created by glial cells. So all the myelin in your body, all of this protection that you have that is caused by the myelin is by the glial cells. There's two different types of myelin. There's myelin in the central nervous system, and there's myelin in the peripheral nervous system. In the central nervous system, it's oligodendrocytes, and in the peripheral nervous system, it's Schwann cells. Why are they different? Because they have different functions. The central nervous system pretty much just sits there. It doesn't move. Of course, the peripheral nervous system is your arms and your legs. There's a lot of movement involved, so they have to be a different structure. And for that reason, despite the fact that they're both glial cells, they don't look the same. And initially they thought they were different types of cells. But then they realized, no, these are protective cells. They're both glial cells. In the beginning, when they found astrocytes and they found microglial cells and they found Schwann cells and oligodendrocytes, they thought they were all different types of cells. But they're not. They're all glial cells. They're all protective cells. They're all cells that have a maintenance function. That's what the astrocytes do. I'm sorry, that's what the microglial cells do. They have a maintenance function. So the myelin that surrounds the central nervous system in the brain and the spinal column are oligodendrocytes. As I said, the central nervous system pretty much just sits there. There's not a whole lot of movement involved. So we need a different type of myelin, and this myelin is known as an oligodendrocyte. And they're shaped like little trees, and that's why they have the name oligodendrocyte. Oligodendrocyte just means little tree cell. It's Latin for little tree cell. You know how cool they are about making. If we spoke Latin, it would all make sense to us, but of course, how many people speak Latin? Schwann cells construct the myelin outside the brain and spinal column. Schwann cells are small, and each one will wrap itself around the axon to protect it, and it also accelerates the response. This is really important because when we're playing, or when somebody's about to punch us in the face, one of the things we need to do is to duck. And how do you duck so rapidly? It's because you have rapid response nerve cells, and that's how you do it. That's why you're able to duck. I mean, otherwise you'd stand there, take the punch, and while you're trying to move back, I mean, it would be unnecessary. When you look at the myelin formed around an axon, you will see that the Schwann cells don't touch each other, but they leave a gap between each cell. These gaps are known as nodes of Ranvier, and one of the beauties of the nodes of Ranvier is it accelerates the process. The electric charge will jump from one myelin cell to the other, so it will bounce its way down the neuron, and it will accelerate it up to 112 times, and that's why it works. When an individual suffers a blow to the head, the injury tends to heal slower than a blow to any other part of the body. This is because besides causing localized damage, the glial cells become larger by taking on moisture. It's the glial cells that take on the moisture. And one of the things that we have to do is we have to wait for those glial cells to lose their moisture. Sometimes somebody will be in a coma. And we'll have to wait to see if they ever come out of the coma. One of the reasons they're in the coma is because the brain is trying to protect itself. And the brain protects itself by collecting moisture, by accumulating moisture. Well, sometimes this moisture will put pressure on different parts of the brain. And if it puts pressure, especially on the cerebellum or the brain stem, then that will cause the reticular activating system to be activated, and it will put the person, they'll go into a coma, and that's what a coma is actually. It's pressure on the reticular activating system. So if that's the case, of course, they'll stay in a coma until the pressure is relieved. Now, in the old days, we didn't really have very good analgesics. And that's the purpose of ibuprofen. Ibuprofen releases, it dissipates some of that moisture. So if you take, sometimes you will injure yourself and you just don't seem to be able to recover. And the reason is because you still get that moisture in that area. So if we can reduce the amount of moisture in the area, sometimes you'll recover 100%. So that's one of the things that we need to do. And now, of course, we do have ibuprofen. Aspirin doesn't work nearly as well. Tylenol doesn't do that at all. But now we have ibuprofen to reduce the swelling. We also have Lasix to reduce the swelling. Of course, Lasix pulls off a lot of fluid. And so we can give somebody Lasix and pull a lot of fluid off. Some people will, when my dad was dying of congestive heart failure, they had him on a select amount of Lasix. They had him on a select amount of Lasix. It wasn't enough. And he was building up fluid in his lungs and fluid around his heart, which was killing him. And what they needed to do was increase his Lasix. That's what they needed to do. But you know how dumb doctors are. You know how dumb doctors are. Anyway, and they weren't going to do the heart surgery until after the holidays, and here he is, he's dying on a Friday afternoon. And of course, everybody's going to take Monday off, right? Okay, well, anyway. So my mom was going to let him die. I mean, my mom, she was so pissed. because my mom's a nurse, so she understands how stupid doctors are. And she thought, wow, it'll serve him right if Nick dies. That was what she said. Anyway, so I called the doctor and I told him what was going on. They said, oh, when did you bring him into the emergency room? You know how doctors. Oh, we would have been there in 15 minutes. No, you wouldn't have. Dumb shit. You would have said, oh, it's a holiday. Why don't you come back after Labor Day? It was Labor Day. Anyway, he had the surgery and he lived for another 10 years. So there you go. The nervous system of the human body can be subdivided into two nervous systems. The central nervous system, which is your brain and your spinal column, and then all the others. All the others are known as the peripheral nervous system. Fairly simple stuff. And I've got a wonderful picture of the peripheral nervous system and the central nervous system. It's just the brain and the spinal column, and then all the other nerves. And that's of course your peripheral nervous system. Why doesn't it work? Anyway, peripheral nerves are categorized by what part of the central nervous system they are connected to. Cranial nerves are connected directly to the brain. Spinal nerves are connected directly to the spinal column. Autonomic nerves in the autonomic nervous system are connected to glands and organs that trigger automatic responses from these areas. So cranial nerves are connected directly to the brain. Spinal nerves are directly connected to the spinal column. There are 12 cranial nerves that control sensory or muscular movements in the head or the neck. Now this becomes very important, especially if we have paralysis. If somebody has a stroke and half of their face is paralyzed, or somebody has a traumatic brain injury and now all of a sudden they can't move parts of their face. They have a hard time with their eyes. They have a hard time blinking their eyes. So this is really quite important, and we need to understand where these nerves are. These nerves aren't just singular nerves, they tend to be networks of nerves that control various parts of our faces. We have the facial expressions that we have because of the intricate nerves that run through our faces in order to make us able to wink. Some people can't wink with both eyes. To blink is very important. As humans, of course, we communicate through our facial gestures. And all of these facial gestures are quite important. The fact smiling is important because it tells people that you're not dangerous. Frowning is important because it tells people that you're unhappy. Anger is important, the facial expression you make when you're angry, because it tells people to leave you alone. These are all quite important, and this is one of the reasons why humans, if you look at other animals, they don't have the same facial expressions. They're people. I've done something, and well, I haven't done anything. That's the problem. I can't make my PowerPoint go to the television.
Screen.
The screen, yeah. We don't have there's not a clicker. I'm not a clicker. Just out of your way.
Tree break.
Make it work. What did I do?
What did we do last time? We got out of here and set it back up.
It was working, and I think it's because Jeremiah was in here playing with it. And I know that Marcus was in here, and it was working for him yesterday.
We're getting these things all set up for final installation, so the guys were doing stuff to it, so they probably,
So I know it was working yesterday.
yeah. This guy's working on this right now, so they probably made some changes and forgot to set things back.
USB. I kind of played with it a little bit, but I couldn't get it to work. Obviously, since it wasn't working. Of course, I feel so stupid when I can't get these things done.
I'm bad with technology. I don't.
I didn't hear you volunteer to go.
Yeah, sorry. I'm the last person.
Yeah, I'm not tech savvy either. I'm kind of type like this.
Yeah, I'm a two-finger typer myself.
My wife can just talk to me and just type.
108?
I'm just like, no. Shoot, you type too, right? Kind of have to at your job, huh?
Great, I need a telephone that works.
Hey, Bruce, I got a quick question.
Sure.
So, when I came back stateside, right?
Right.
I was getting shots right here,
Okay.
nerve block shots. What was it for?
What were your symptoms? What were your problems?
Migraines.
Migraines?
Vertigo.
Okay.
Nausea.
Were you having any, did you have really bad tinnitus? Tinnitus? Ringing in the ears?
That.
Okay. That's what they're trying to relieve back here. See, this is a hearing portion of your brain. This is the eyesight portion of your brain.
Okay, they put 2 in each shoulder and 2 in the back of my head. So it was even worse because, you know, shit in my head.
Sure.
She goes, oh, you ready? I'm like, a little needle. It's like this big motherfucker. Alright. It's so bad that like someone had that
You had
scorpion.
a hole in that part of your skull? That
No.
there must have been, because you can't stick through the skull with a needle.
It was right here. Right here.
Okay. Wait a minute. Oh, they were going underneath the skull.
Yeah.
Yeah.
That needle was pretty damn big.
Yeah, it was big. It needed to be big in order to.
For about
To go
4 months straight, every Thursday.
Is
It
that
was
right?
cool because I had quarters the next day.
Right.
So it was that 3-day weekend, but the next day I couldn't even freaking get up anyways.
Well, you couldn't function anyway. How in the world, were you on active duty at the time?
Yeah.
And you
I
were
was
going-
active duty.
Yeah, but you weren't going to work. I mean, how could you with vertigo? And-
I would do office, it's just
Jeez, the military.
usually about 10 o'clock, first one will be, I fuck out of here.
Well, yeah, but what they needed to do was just send you home and let you rest. That's what they needed to do, not make you go to work. That just slowed down your recovery.
I'm all right now.
Yeah, but how long ago was that?
09.
Oh, 09.
I did it.
10 years.
Yeah.
10 years. How long did it take you before you were completely functional again?
Completely?
Yeah.
Maybe 6 months.
Oh, 6 months. That's not so bad. But I wouldn't have put you on active. I mean, I wouldn't have let you go to work. I'd have put you
Well,
on.
it was crazy because I was a team leader, so like I had to be there. I told Doctor I wanted to watch over my guys.
You couldn't go out in the field. Why in the world didn't they make somebody else the team leader? Not the Army.
Because they're my guys.
I know. The Army's so stupid. Oh, did I say that? Wait a minute. Oh, I said it on tape, too. I've already said doctors are stupid, now I said the Army is stupid. The Army is dumb. The military is dumb. They want to get, your active duty, and they have 2 choices. They can either board you out, medically board you out, or they can wait until you recover. But for some reason, they don't feel like they can just send you home.
I got out 5 years later though.
Yeah, well, yeah. I guess it didn't work for them. They were hoping that you'd recover. We do see that a lot with TBI, spontaneous recovery. Your brain is healing itself. It's not just healing itself, it's also repairing itself.
It was weird, like some things, I can't drive at night. I can't see, but like I said before, I think it's for me wearing the MVGs. for so many years
Sure,
that maybe it's that night, you know?
that's a
I don't
possibility.
know, but I keep glasses in the car so I can see at night. But
Well, I mean,
it's like a hit or miss.
other people wore those things for as long as you, or longer than you did. So the question is, do they have the same problem you have?
I don't know.
The fact that you can't see at night.
But I got, or I had bone and cartilage floating around in here. I boxed before I joined the army.
Well, that was from when you were a civilian.
Yeah.
You got punched in the eye
Yeah.
and knocked off a chunk of cartilage.
Yeah.
Oh, jeez.
But, it was good.
Have you, I lost your page here.
Oh, that's okay.
I'm trying to figure out, I don't work with mine, whatever. I have a feeling they're still working on it, they were doing the new upgrades.
Is that what you want?
Yeah.
Okay. Well, what it was showing before was whatever was on my screen was up there.
How do you even, I'm totally unfamiliar with Macs, how do you tell your machine to present on the,
Like it just does it. It's a Mac. Macs are brilliant. What are you looking for?
your pointer here?
Yeah, what did you do with it?
Swap displays.
I don't know what you did with it. What's going on? Here. Oh, there it is.
See, I can't even, when you go back to your regular, what your presentation, I couldn't even tell it to,
To go up there?
yeah.
I can't find you the other. Is that what you want?
Mhm.
Okay. We got enough. So they were playing with it and they.
Yeah, well, they're finalizing the installation to where everything's integrated
Okay.
and online, so that might be an issue that, but, I mean, they should have left it to where you would have been able to show it.
Sure.
And the last one we did, I think we closed it, completed, and we got back on the presentation and automatically went to there.
Right, that's an apple for you. Okay, turn it back
Try
on.
that. Let's try that again.
Okay.
And it's not allowing me to change to uplinks up there.
Right, okay.
So that tells me it's might be not finished.
Okay. Okay. Well, it was working before, it was working yesterday.
Yeah, they did some work as of yesterday,
Okay,
yeah, so
okay.
they were working at it.
We'll go back and slap them a couple times.
Yeah, I'm supposed to have finished this whole thing by Friday, so.
Oh, okay, fantastic. So we won't have to worry about it after today. All right, thank you.
Yep, sorry.
I'm sorry that we couldn't get it.
I'll try to get you an update here soon.
Okay, fantastic. I appreciate your help. All right, so what are we talking about? We're talking about the cranial nerves. There's 4 cranial nerves for the muscles of the eye and eyesight sensations. And of course, if you have a problem with any of these cranial nerves, which run directly back into your brain. So having problems with those cranial nerves is not very common. Doesn't happen very often, but it can happen if there's any degeneration in that area. There's 4 control muscles of the neck, the face, the tongue, and the sensations of the tongue, sinuses, and throat. And of course, if you have problems with these cranial nerves, then you have a hard time making facial expressions, you have a hard time swallowing, you have a hard time clearing your sinuses, which is really kind of interesting. One controls the sensation of the inner ear, and this may be what Scott was talking about. The inner ear, of course, has to do with balance, has to do with vertigo. So if you have a problem with this cranial nerve, then you would have vertigo, perpetual vertigo. The vagus nerve, of course, controls the heart, lungs, and digestion, and it runs from the brain all the way down to your abdomen. There are 31 pairs of spinal nerves. There's one on each side of the spinal column, so there's 31 pairs, one on the left and one on the right. This gets to be really interesting. Humans, of course, we evolved Being symmetric, we needed to do things with our left sides and our right sides. So when you are a baby, one of the things that babies will do, they'll be right side dominant or left side dominant. One of the things that they will do, if they're right side dominant, they'll move their left side a lot. Now people think, oh, they must be left-handed, but no, that's not true at all. What's happening is they're right side dominant, so they do everything with the right side, and they need to become symmetrical, and so they work the left side. Babies are that smart
Yeah.
that they're able to make themselves totally symmetrical.
How about babies that tend to use both hands?
They're ambidextrous?
Yeah, because I've seen,
Do they turn out to be ambidextrous later?
yes, that's
Okay.
what I mean. Because I attended a preschool orientation for my nephew, and him and his little side, his table, whoever he sits with, they tend to use both sides of their hands. And I seen them draw on this side, and then they switch, and then they do the same with the other side.
Oh, they draw with both hands?
Yeah.
Oh, that's
and
interesting.
They both of them do that together.
My
It's like-
son, he catches right, but he throws left.
Well, if you catch with your right, you throw with your left.
Or no, he
Okay,
switches.
so when he
He
plays,
switches.
when he plays with the football, he'll throw
Right-handed.
but he catches on this side. When you throw the ball at him, it goes like this.
Well, in baseball, of course, you wear a glove on one hand, your non-dominant
switch it.
hand, and then you catch with one hand, take the ball out of the glove and throw with the other hand. So whichever hand you throw with, you catch with the other hand.
He does it with both.
And that makes you ambidextrous to an extent. We tend to be right eye and left eye dominant. Most people are right eye dominant, and that's why guns are put together the way that they are, because almost everybody is right-eyed. But if you're left eye dominant, then you have to shoot cross-eyed.
Or pay a lot of money and get it custom.
Yeah, but the military won't give you one of those. I had a friend, he was Nez Perce. I don't know if you know anything about the Nez Perce, but they are amazing. They have these amazing skills with rifles, with weapons. And he was left eye dominant, and when he joined the military, he shot expert, of course, but he was shooting cross-eyed. So he was aiming, it was one of these things. Oh, wait a minute, it was like this. So he was putting his left eye, so he's using his left eye to aim with. And of course, they didn't want him to do that, but of course, he was hitting the target every time. I mean, he was hitting it right in the center.
That's all that matters at the end of the day.
I'm sorry?
That's all that matters at the end of the day.
Well, yeah, is hitting your target. Left-handed people, of course, with an M16, they're catching all the discharge in the face. But they can, of course, shoot left-handed. And they put a special something on it to deflect all the rounds, all the shells from going out the wrong direction. Anyway, they didn't do that when I was in the service, of course. They do that now with the weapon that you guys are using, which is a much more sophisticated weapon than the M16 that we used.
You guys had the A1s?
Of course, they didn't call it an A1 then. We had the M16 with a plastic handle and a plastic. Yeah, what you guys have is much more sophisticated than
Well,
anything.
we had A2s.
Okay.
And then we went to infantry school, it was the M4 carbon,
Okay.
which is pretty much M16.
Right, shorter version of the M16, exactly. Not that any of this is important, except the military people who aren't shooting those weapons anymore. Okay, so we have 31. I know. Yeah, I shot with the M16. The stock was loose. It's a long weapon.
Musket, money musket.
Yeah, it was pretty good. It was a long weapon. Well, it wasn't longer than the M14. The M14 was a lot longer than the M16. There are 31 pairs of spinal nerves, and of course there's one on each side of your body. There are 5 segments to the spinal column. This becomes very important because if you have damage to your vertebra, then we need to know where that damage is. There are 8 cervical nerves. Cervical is a word that means collar. Collar. They're in your neck. There's 8 of them. There's a lot of them. There's 8, and they're relatively small. If you're in an automobile accident and get whiplash, they have the natural curve to them, and there's supposed to be a curve. If there isn't a curve, if they straighten out, now we got all kinds of problems with your cervical nerves. You get headaches and whatnot. Uh-oh, he's got it. You can fix it.
Sorry to interrupt.
That's okay.
I was asked to go ahead and suggested unplug your cable that plugs to the TV. Let it sit for about 5, 6, 7 seconds.
Okay.
Then plug it back in.
Okay.
And it should recognize that I was told.
Okay.
If not, then there's still issues.
Okay.
Give it a shot, maybe twice. Thank you.
You bet. See you later. Kevin. It's fine. Okay, let's try it. Hold on. Okay.
Just unplug the TV.
I don't think we can.
Yeah, you see the plugs right here?
No, let's not do that, let's not do that. So, Kevin's standing right there. If you do that, then and it breaks, then guess who gets blamed? Not you. So as we move down the vertebral column, we start out with the 8 cervical nerves. Cervical just means collar, just collar. There's 12 thoracic nerves. Those are in your torso. Your torso, of course, this is where you do all your, this is where you do your breathing, but it's also where you move your arms, controls the movement of your arms. There's 12 of them. Thoracic means brace in Latin. Moving down, this is the area that is the most problem for most humans is the lumbar region. There's 5 cervical nerves, or there are 5 lumbar nerves. This is your lower back. Lumbar just means belt. That's all it means. One of the reasons we have so much trouble is because if we're trying to lift something from the ground, then we're using, and we're straightening up, then we're using our lumbar, our vertebra, in order to do that. So what they try to do is they try to train you to use your legs so that you're not just using your lumbar region. People that do a lot of heavy lifting tend to have back problems, and the back problems, of course, are in the lumbar region. And sometimes those nerves get pinched, and of course you need surgery on your back, and it's usually right there in the lumbar region. People rarely have problems with any other part of their body. As I told you before, my wife was in a Bradley vehicle accident, hit her neck, and she had to have her cervical nerve, or cervical vertebra fused. She had, there are 8 of them, wait a minute, yeah, there's 8 of them. She had 4 of them fused together, so she can't move her neck from side to side. She has a hard time bending over, but it has relieved her pain. Her pain was going all the way down into her neck and into her shoulders because of her cervical problem. There are 5 sacral nerves, and these are the ones that are in your butt. This is in your pelvic region, of course. Sacral just means girdle. And of course, most people don't have problems with this because you have lots and lots of muscles right there. The biggest problem you have with your lumbar region is that you don't really have that protective of muscles in that area. If we're talking about your sacral region, your pelvic region, it's a huge bone. It's very stable, and you've got all of your gluteus maximus muscles to protect it. So you rarely have problems with your sacral area unless you're in some kind of an accident and you fall and you hit that portion of your body. Normally it's in the lumbar region, and the reason is because you've got your abdominal muscles trying to protect your lumbar region, but if you're bending over, of course, you're neutralizing these muscles that are protecting your lumbar region. And you don't have that many, your back muscles just curve into that area, and there's really nothing protecting your lumbar region. So if you're making a movement where you're bending over and picking something up, there's really no muscles protecting that area. Normally you have your abdominal muscles, the muscles in front, but your abdominal muscles are really not to protect your lumbar region, it's to protect your intestinal tract. It's to protect this portion of your stomach. So there's a lot, if you're going to damage something, usually it's the lumbar region, unless you're in an automobile accident, or like my wife was in that Bradley vehicle accident, and she injured her neck. There's one coccygeal nerve. It's right at it's your tailbone. It's easy to fracture your tailbone. It's easy to fracture this area. But usually there's no nerve damage when that happens. And of course, coccygeal means tailbone in Latin, as curious as that is. So your vertebral column is very important. Your vertebral column has a natural S shape to it. We do some really strange things in order to get that, to accentuate that S curve. People will wear high heels, and when they wear high heels, of course, it tilts their foot up, and if you tilt your foot up, it tightens your calf muscles, making your calf muscles look better if that's what you're looking at. But it also makes you stick your butt out and curve push your chest out. So you're walking around like
That's
this.
how they do it.
That's why they do it, to make their butts, stick their butts out and to stick their chest out. If women wear flats, of course, they're pulling their pelvis in and they're pulling their chest back. So it has to do with the S curve. Now, strangely enough, high-heeled shoes were invented by a man, for a man. It was Louis XIV with the king of France, who evidently had skinny calves or something. I don't know. Anyway, he wanted to look better, and so he walked around in high heels and stuck his butt out and stuck his chest out. So there you go. It was a man that didn't want to lift weights. To look better, he wanted high heels, and it worked. The autonomic or automatic nervous system is divided into two nervous systems: the sympathetic nervous system and the parasympathetic nervous system. The sympathetic nervous system prepares you for action, shuts down normal function, it increases your power stores, and it increases your sensory activity. So if you get excited, and of course the excitement comes from adrenaline, or it comes from a situation, and then of course adrenaline is pumped throughout your body, then the sympathetic nervous system kicks in. One of the problems with the sympathetic nervous system is that if you excite the sympathetic nervous system, if you're an anxious person, then you're exciting the sympathetic nervous system all the time. And if that happens, then your body is only geared to be excited a select amount of times in your life. If you have too much adrenaline pumping through your system on a continual basis, then you're actually accelerating your life process. It's kind of like taking speed. I mean, that's what adrenaline is, or that's what speed is. It's just like adrenaline. So if you're one of those nervous types, you're a type A personality, potentially what you're doing is you're forcing yourself to live a shorter lifespan because you get excited so often. Which is kind of sad. Anyway, so what happens with the sympathetic nervous system? Sympathetic nervous system dilates your pupils, improving your eyesight, so your pupils get larger. It inhibits your salivation, causing dry mouth, because of course we need to decrease the amount of digestion. It's a waste of energy to digest food while you're trying to fight off a bear. It relaxes your airway, allowing deeper breathing. so that if you get into that kind of a situation, that you will be able to control your breathing. Instead of panting or gasping for air, now you're breathing relatively normally. It accelerates your heart rate so that all this excitement, you're able to do something with it. It stimulates your sweat glands so that, stimulates your sweat glands so you get what they call flop sweat. It stimulates your liver to release energy stores, so now you have more energy. It slows down your digestion to the point that it almost stops it. So if you're in a really stressful situation, potentially you're not digesting food for maybe an extensive period of time. So whatever you take into your stomach is going to sit there and not digest. So you're going to be burping whatever you ate. You're going to be burping it for hours after if you get too excited. It inhibits your kidney function. So all of a sudden you're not processing urine anymore. And this can be a problem. It constricts your blood vessels in the skin, making you look paler than you did before. And when people see you, they'll say something like, "Are you okay?" Because you look pale. Looks like you're about to pass out. But you're all excited and ready to go. And that's a good thing. Once upon a time in Indiana, when I was going to college, I was married and I had a little baby. I was also running track, and I was also in student teaching. Well, one weekend my wife decided that she was going to leave me because I wasn't any fun. So all weekend she argued with me, and so it started on Friday night, and we're arguing on Saturday, and she's saying, "I'm going to leave you, I'm going to leave you, I'm going to leave you," and I'm saying, no, don't do that, don't do that. I'm taking the baby and I'm leaving, and this is all Saturday. Sunday, we packed the car to take her back to her mother, and halfway to her mother's house, she decided, no, she'd stay with me. Okay. Isn't that a wonderful story?
So you would have taken her, man.
No, I'm not going to say horny on the tape. Anyway, so I took her back home. On Monday morning, I had to teach. So I don't know if you've ever student taught. Well, of course you haven't student taught. But student teaching is very traumatic. It's not the easiest thing in the world. Anyway, so I was student teaching on Monday. That afternoon, we had a track meet against Butler University. You guys probably have heard of Butler because they play in the national basketball tournament practically every year. They were a Division III school at the time, but they were bigger than we were. They were like twice as big as we were. So they had really good runners, and we were supposed to win this track meet. And of course, being the captain of the team, I wanted to do my best and run faster than anybody else did. And during the track meet, I didn't do very well. I did very poorly, as a matter of fact. I couldn't run the mile relay. I collapsed and started vomiting, and they couldn't figure out what was going on. So they thought I had the flu. They sent me to the hospital. When I got into the hospital, they did all the blood tests and all the urine tests. And what they discovered was that my kidneys weren't functioning. They had stopped. They'd stopped functioning. So, I've got kidney failure. That's not good. So they pumped me full of fluids. They were thinking of giving me dialysis. But about that time, my kidneys started functioning and everything was better. After I slept, I went back to normal. And of course, they kept me in the hospital for a week, checking my kidney functions, shooting dye into my veins and whatnot. What had happened was that it was such a stressful weekend, and I had been under that much stress for such a long period of time, from Friday night until I collapsed on Monday, that my sympathetic nervous system had been going overtime, and my kidneys, which of course are one of the things that slow down, had completely seized. They had completely stopped because of all the stress. And I had actually poisoned myself, because your kidneys, the job of your kidneys is to cleanse you of all these toxins in your system. So normally you have your kidneys cleaning out your blood and taking all these toxins out of your system. Well, I didn't have that. So because I didn't have that, I had this buildup of toxins, and that's why I was vomiting, and that's why I collapsed, and that's why I was having so much trouble. And I was in the hospital for a week, and they were afraid my kidneys wouldn't start up again, but they did. They started up. Now, oddly enough, about the same time, Joe Frazier and Muhammad Ali were having a boxing match in the Philippines, and they called it the Thrilla in Manilla. If you remember the name, the Thrilla in Manilla. And Joe Frazier collapsed after the bout. Ali won the fight. They took it to 15 rounds, and at the end, Joe Frazier could barely raise his arms. And the reason is because he had exactly the same thing I did. His kidneys had stopped functioning, and they had stopped functioning for a long enough period of time that by the end of the fight, the toxins were building up in his body. And they took him to the hospital, and they kept him in the hospital for a week. They fed him all this stuff, and they called it athlete's kidney, because this is very common among athletes, where they're all keyed up for an extended length of time, and their kidneys stop functioning. And that happened to me, and it happened to Joe Frazier about the same time, which is kind of exciting if you think about it. Joe Frazier and I are identical twins, as strange as that may seem. But anyway, so that's the sympathetic nervous system. The sympathetic nervous system gets you going. It pumps adrenaline through your system. All of these functions of your body slow down and stop so that you will have the energy, you'll have the wherewithal to be able to function. Now, I've been in very stressful situations for extended length of time since then, but it was never, I never had my kidneys stop functioning again in my life, despite the fact that everybody said, well, this is going to be a recurring problem with you, you can't handle stress, or if you have prolonged stress, then your kidneys are going to stop functioning. I've never had it again. I've worked in emergency rooms, I've been in combat situations, and I've never had the same thing. That same thing has never happened to me. Again. But then again, maybe facing the Viet Cong was easier than facing my ex-wife. The idea of losing, and it wasn't losing my wife that bothered me as much as losing my baby. She's going to take my baby away. That would have been a tragedy. Beyond a tragedy, and that's one of the reasons why I had the problem. Okay, so the parasympathetic nervous system returns you to normal. So all the things that the sympathetic nervous system does, the parasympathetic nervous system just reverses the process. Your pupils constrict, stimulates salivation. As a matter of fact, you may have a difficult time swallowing all the spit that you're producing at that point. It constricts your airways, so you start breathing differently. If you are not aware of what is going on, you may hyperventilate, and that's not a good thing, but you may hyperventilate at that point, whereas you go into a form of shock. Your heartbeat will slow, it stimulates your digestion, so your stomach will start rumbling, as much fun as that is. It dilates your blood vessels in your intestines so that you start functioning. You may get diarrhea after your nervous situation. It dilates your blood vessels in your skin and you flush. The other thing that happens is when you flush, it may make you feel like you have a fever. It may make you sweat profusely, as interesting as that is, the parasympathetic nervous system. The average human brain weighs about 1,400 grams. That's about 3 pounds, a little less than 3 pounds. The major part of the brain is the cerebrum, which is divided into 2 hemispheres. Intellectual capacity seems to be contained in the surface area of your brain. So it's right on the outside. The surface area of your brain is increased through the ridges and folding that triples the surface area of your brain. The convolutions are called gyri, and the furrows are called sulci. So the mountains are called gyri, and the valleys are called sulci. And that's the way your brain is. And you've got all of these mountains and valleys in your brain. If you've ever seen a human brain, it's very intricate. It's got lots of wraps and folds and lumps and chunks and whatnot. They used to do what they called phrenology, where they were feeling these lumps. Actually, they were feeling your skull and assuming that you had lumps where there were lumps in your skull. Has nothing to do with nothing. The phrenology has nothing to do with anything. The brain contains four fairly distinct lobes that have four fairly distinct functions, and this is what we were talking about. This is what Scott and I were talking about before. The frontal lobe is where all of your thinking takes place, right in the front. So if you get punched in the forehead a lot, if somebody slaps you in the head, and if they keep hitting you in the front of the head, if you play football and you put that damn football helmet on and you keep banging that in front of your head with somebody else, the front of somebody else's head, potentially you're damaging the thinking portion of your brain. If you play soccer and you do a lot of heading, where you jam your head forwards and hit that ball, the ball, of course, is relatively soft, but when it hits your head like that, it's like hitting your head against the wall. And of course, that can do damage to you as well. So athletics, a lot of times, you're using the wrong part of your head, and you're, of course, it's causing damage. I am a fan of the San Francisco Giants. I follow the Giants, not religiously. They lost last night, 3-2. But over the last 3 or 4 seasons, they've had a lot of individuals that have had concussions, and it's because they've come on in. They've caught a ball in the forehead, and it's done a lot of damage. It's done damage to them, so they had to sit out. They had a concussion.
Am I in the right class?
Yeah, you're in the right class,
Okay.
but you're about 14 minutes early. That's okay. That's okay. Anyway, so you've got, this is where your intellectual functioning is. That's the frontal lobe. The parietal lobe is right behind it. It's right on top of your head. It controls your body movements. So if you have damage to this portion of your head, you'll have a hard time walking. You'll have a hard time moving. You can't grab things like you did before. So, this is one of the things that you have to look at. So if you have a blow to the head, one of the things that we do is we try to determine how much damage is done, and we do that by saying how many fingers am I holding up, because the sides of your head, this is where your hearing takes place. So if you have a blow to one side of your head, what we get is a rebound reaction. So if you get hit here, you also get hit here, because your brain is in there bouncing back and forth. So if you get hit here, then you're also hit down here. Your brain is hit down here. So that's why we hold 3 fingers up. The reason we're holding fingers up is because we want you to see things. We want to know if you have damage to your occipital lobe, which is in the back. This is your temporal lobe on the side. This is your parietal lobe on the top. This is your frontal lobe in the front. This is where your thinking takes place. This is where your movement takes place. This is where your hearing takes place. This is where your eyesight takes place. So if you get hit in the head, we're going to hold up fingers and ask you, how many fingers am I holding up? For one thing, we want you to think, how many fingers am I holding up? So you have to think, I see 1 finger. If you can't see, of course, then now we know that there's damage to the occipital lobe. If you can't understand what we're saying, if you can't hear us, then there's damage to the temporal lobe. If you can't process the information that we're giving you, then you have damage to the frontal lobe. And of course, if you go to run it back out on the field and running kind of crooked, we know there's damage to the parietal lobe. Okay, and that's the reason we do the things that we do. And there are in between innings, if somebody gets hit in the head, and this happens to catchers all the time, foul tip and it'll hit their mask, it can cause damage to their brain. So when they come in off the field, or they'll go out on the field, the coach or the trainer will go out and they'll ask them questions. Well, who's the president of the United States? You know, how many, they'll hold up fingers, because if you get hit here, it rebounds and it hits you in the occipital lobe. So your brain is in there and it's suspended on a stalk, and you've got this hard covering, and the brain is moving back and forth. It can move in there in all this fluid. So if you get hit in one place, you get hit in the opposite on the opposite side of your brain at the same time. So you could get hit here in your frontal lobe, and of course the rebound is back here in your occipital lobe. So your eyesight would not be as good as it was before. So they were injecting you, trying to help you recover from your trauma.
For the longest time, I couldn't remember my social security number, but I know my rifle serial number, like that.
Your
7130974.
But you couldn't remember your social security number. A number that you had had all your life, but you could remember your rifle serial number. That's interesting. Okay. So in between you have two hemispheres of the brain. The brain was put together so that you could lose portions of your brain. As stupid as that sounds, we as humans, of course, don't want to die if we get hit in the head. So we have two halves of our brain. We have a left side and a right side. They kind of do different functions, but they can do the same function if necessary. Connecting the two hemispheres of the brain is a muscular connector called the Corpus Callosum.
What exactly is this? Is it like muscle or what?
It's nerve
That
cells.
stuff.
It's myelinated nerve cells.
Oh.
So if information needs to go from one hemisphere to the other hemisphere, it goes through the corpus callosum. The two hemispheres are not connected except right there at the corpus callosum. So the corpus callosum is very important. It is the communication between the two halves of the brain.
Just a telephone line.
Yeah, it's a telephone line, exactly. Now, women have a larger corpus callosum than men do. And for that reason, they have more communication going on between their left hemisphere and their right hemisphere. So if they have damage to the brain, they recover faster than a man will. And it's because they can reroute the information that is necessary in order to maintain the same functions. Okay, that's the good news for women. And that's the bad news for men. So if a man has a stroke or a TBI, it's going to take a man longer to recover from the TBI than it will with a woman. I was working up in Montana, and there were a set of twins. One was a male, the other was a female. And they both had a stroke at the same time. They were both shooting up with crystal meth. And they both had strokes at the same time. And they went in, and what they discovered was that his damage wasn't as bad as hers was. They both had strokes, but her damage was more extensive than his was. It involved more of the brain. But it took her like 3 months to recover. It took him 6 months to recover. And he never recovered completely, but she did, as interesting as that is. And she had more damage to her brain. Well, that's because she's a female, which doesn't seem fair at all, but that's just the way it works. So why would females need to be protected more than males are? Women represent children. Men represent, I don't know what they represent, not children. But a woman equals one baby. A man equals, I don't know, nothing. He doesn't represent squat. But she represents a baby. So she's got all this stuff. She's got this stuff running through her system that protects her. Estrogen. Estrogen protects her from lots of different things. Kidney stones, heart problems, any problems that a man potentially has, estrogen protects her from that. So a woman is much hardier than a man is. She can sustain a lot more damage than he can. he's made to, I don't know, maybe he's a drone, like one of those bees that just run around and protect the hive or something. That's what a man's for. But female is each female equals a baby. So they're far more important, I guess. Anyway, so the two hemispheres of the brain are connected by myelinated neurons called the corpus callosum. The corpus callosum is very important. When this big thing starts working again, I'll show you what happens to babies when their mother drinks. One of the things that happens is that, of course, it does brain damage to the child. Potentially they can recover to some extent, but if it's severe FAS, fetal alcohol syndrome, if it's severe, what happens is it decreases the size of the corpus callosum to the point that it's like not there at all, which is beyond tragic, because this kid didn't do anything except grow in a mother who couldn't stop drinking, as sad as that is. So the brain damage is just extensive. Not only that, but if you look at the brains of a baby with FAS, the gyri and the sulci are not nearly as extensive as a baby that's born to a mother that doesn't drink, as sad as all that is. Now, like I said, eventually, of course, they can recover to some extent, but they don't have to have an intellectual deficit, but of course it is going to cause all kinds of interesting problems for the individual, and it was just because she couldn't put the bottle down, as tragic as that is. Anyway, there you go, corpus callosum. In normal circumstances, it's nice and healthy, and it's nice and large. Wait a minute, let me make sure I'm not doing this. I'm going over. Okay. If we cross-sectioned an individual's brain, we would see that some of the brain is made up of tightly packed, non-myelinated neurons that look gray. This is your gray matter. Other areas look white because the myelinated neurons that make them up, they're white. The myelin makes them look white. So if we look at the brain, we have gray matter on the outside, we have white matter on the inside. Researchers have found that the larger the gray matter of the brain, the more intelligent the individual is. We're constantly making neuronal connections, and these neuronal connections are mostly in non-myelinated areas of the brain. And that makes us smart. So the more gray matter we have, the smarter we are, the more intelligent we are. The more white matter we have, the less intelligent we are. As odd and curious as that is. As the baby begins to develop from ever-expanding numbers of cells, the brain and the nervous system begin as a structure known as the neural tube. It's one of the first things that develops in the baby, is the baby's brain. In the beginning, the smaller, more primitive parts of the brain develop before the intellectual portion of the brain, the cerebral cortex. So the first thing that develops is the spinal column, and then the primitive brain develops. The medulla, the pons, the cerebellum, all the movement portions of the brain develop. And this, of course, is considered the reptilian brain, or it's the more primitive portions of the brain. I have a really neat video, so when we get this thing working, I'll show you that video that shows you the neural tube developing. And the neural tube, of course, as it develops the most primitive portions of the brain first, and then eventually, of course, the intellectual portion starts working. The cerebellum surrounds two areas that scientists considered an evolutionarily old part of the brain that they sometimes refer to as the reptilian brain. There are two portions to the reptilian brain, the basal ganglia and the limbic system. Basal ganglia means basic nerve sheath, and limbic system means border system. And so these are the middle of your brain. It's right in the middle of your brain. If we look at any vertebrate, what we see is this portion of the brain is very much intact. All right, why don't we stop right here? And since I'm going to play with this thing and maybe get it to work. Well, you never know. I mean, Kevin couldn't get it to work. I know.